Okay, hi. Just like to finish this example. So just to quickly recap, we had a sample from a normal with distribution, unknown mean, variance 1, and we were testing the test whether mu is equal to mu 0 or the alternative hypothesis that it's not equal to mu 0. And we compute our likelihood ratio test statistic by taking the likelihood at mu 0, which is just a single value, and at y bar, which we knew was the maximum likelihood estimator. So that will maximize the likelihood when you're unrestricted as to what mu can be. And down there, the next line, I compute the likelihoods. I make cancellations. It's a bunch of algebra now. And I end up here at this last step where I get the statistic is this. It's an exponential of a negative exponent, and the magnitude of this negative exponent depends on how far away y bar is from mu 0. So the further y bar is from mu 0, the smaller lambda of y the likelihood ratio test stat will be, and the more likely, because of the form that we reject, if lambda y is less than k, the more likely we will reject h0. Further y bar is from mu 0, more likely we reject h0. So I can, just to finish, we still want to put find k, or find the exact test to satisfy that the probability of type 1 error alpha should be 0.05. So I'm going to just manipulate this slightly by taking logarithms. So if let me see if I start, so if I have that step, I could now argue that if I take this and I want to reject it, this is less than k, well, that condition is equivalent to if I take the log of both sides, because log is an increasing function, so the inequality maintains the same direction, and I get this is equivalent to minus n over 2 y bar is less than the log of k. Okay, so let's continue now on here. So that's equivalent to that, and now just another quick multiply by minus 2 over n, so I get that. Now the inequality flips. Should be greater than this number. Don't worry, this is minus, but this is minus 2 because k is less than 1, so it's a positive number. Okay, yep. And could be quite big, actually, because ln of k could be arbitrarily big. Arbitrarily big negative number, so the whole thing could be a big positive number. Okay, so then I get down to here. This is the same as this. I've taken the square root. So these are all equivalent conditions. Now I can just replace this with c, and I could just use this as the test. I don't really ever have to go back to the k. So, so we notice, so let's write this down. So the test, so y minus mu 0 greater than c is equivalent. So it's also the LRT for this test. Hope that doesn't confuse you, the word also. It is the same test, so it's just a simpler way to write it. So if we want to set probability of type 1 error equal to alpha, well, how is, this should be y bar. How is y bar distributed? We want, so note that under h0, y bar is normal, mu 0, that's the under h0 part, and then 1 over n is the variance, right? So we reject, so remember alpha should be equal to the probability we reject, so probability y bar minus mu 0 is greater than c, given mu equals mu 0, and this is equal to, let's make this standard normal. I'm going to divide by the square root of the variance both sides, so this is the probability that z, absolute value of z. So the square root of this is 1 over the square root of n, so I divide both sides by 1 over the square root of n, and here I get c square root of n. This is now gone. I use this to get a standard normal, right? Okay, so I need this to be alpha. This tells me that c square root of n, so c root n should equal q norm of 1 minus alpha over 2, right? Because then there's an alpha over 2 probability that z is greater than c square root of n, and an alpha over 2 probability that c is less than minus c square root of n. Okay, or which gives c is equal to q norm 1 minus alpha over 2 divided by the square root of n. Did I make any mistakes? Does that look okay? Make sure. Yeah, it looks okay. So, what is q norm? So for alpha, if alpha equals 0.05, what is q norm of 0.975? You would think I would know that. Does anybody know? I'm doing it right now. Q norm 0.975. 1.96. So it's 1.96 divided by square root of n implies c equals 1.96 divided by the square root of n. Okay, so if n is even like 9, say, well, if n is 9, it's 2/3, right? If n is 9, it's 2/3. You notice here it doesn't have to be less than 1. We can also go back and find out what k is. If you do it, I did it, but I won't bore you with the arithmetic here. But or we can solve for k, solving for k. I find, I find that k equals I get k equals e to the minus 1/2 q norm 0.975 squared. I'm a little worried I didn't do it. I didn't put the right thing in here, so I'll just leave it here. This is what you should get for k. I think I got 0.147 or something like that. Okay. All right, but anyway, that's the idea. Okay, thanks.